So in today's topic, we will be discussing the concept of the crossing of the rivers. Okay, in last video we have studied the river boat problem, the basic of the river boat problem. So in this video we will be discussing the crossing of the river, and also we will be discussing the minimum time taken, in which direction should the boatman should row the boat so that it will take the minimum time to cross the river. So firstly we will be discussing the basics of this crossing of the river. So let us assume, again we will draw the diagram. This is a river. Okay, so this is a river, and let us assume that D is the width of the river. Okay, now according to our vector equation, we know that, let us assume the boatman is rowing his boat in a direction theta, perpendicular to the, in a direction 90 plus theta with the flow of the river. Okay, so this is our velocity of boat with respect to river, and this is our velocity of river with respect to ground. Okay, let us assume this is our velocity of boat with respect to ground. So in actually, if a boatman starts rowing his boat from here, then he will be reaching like this at this end. So let us assume this distance is equal to x, and in mathematical terms, in physics, we call this distance x as the drift. Okay, this drift distance means the boatman should have reached here, but due to this component of velocity Vr, horizontal component, this boatman reached a distance x away from the initial line. So this x is the drift. Okay, now again we can resolve the components, like our vertical components of the velocity will be Vb r cos theta. Okay, in a similar way, our net horizontal components are Vr minus Vbr sin theta. Okay, so in this problem we can directly see that which component is responsible for the crossing of the river. That is our component perpendicular to the flow of the river. This is the component which is responsible for the crossing of this river. Okay, so we can write here the component of velocity which is responsible for crossing the river. Okay, so this component is responsible. Let us suppose we can write here V perpendicular. So V perpendicular will be equal to VBR cos theta. Okay, so this is the component responsible for the crossing of the river. And now which component is responsible for this horizontal drift? So the component of velocity which is responsible for this horizontal drift, that is our horizontal drift. So basically this component is, we can write V horizontal, that will be equal to Vr minus Vbr sin theta. Okay, now here we can write, let us assume, I will again draw the diagram here. I will be drawing here. This is our river, and this is the width of this river. And here we know that the net component of the velocity in perpendicular direction is VBR cos theta. Okay, and net horizontal components are, let us suppose, VB sorry VR minus VBR sin theta. Okay, so here if I want to write what is the time taken to cross this river, so this is the component of the velocity that is responsible for crossing the river, that is V perpendicular. So time taken to cross the river, time taken to cross the river is, directly we will be writing d divided by, let us suppose t is equal to d divided by this V perpendicular component. This V perpendicular is the component of velocity that is responsible for the crossing of river. Okay, so here d divided by VBR cos theta. So this is basically the time which is required for the boatman to cross the river. Okay, now if I want to ask what is the value of this horizontal shift that we are calling as the drift. Okay, this, so the component that is responsible for the drift is the horizontal component, this is the VH. Okay, so in t time how much drift it will provide, that we directly can write, like if drift provided, that is equal to x, we will be writing x will be equal to horizontal component multiply total time taken to cross the river. Okay, so that will be equal to that will be equal to VR minus VBR sin theta. Okay, divided by multiply d divided by VBR cos theta. Okay, so this is the formula for the drift that is being provided by the horizontal component of the velocity in the time t is equal to d by v.